instead of writing or instead of saying as prime factor form right now, because we don't know the variables whether they are going to be prime numbers or not. For example, you have 9k square, so you bring it to the irreducible form, that is 9 multiplied k. Why we don't say that we have brought it to a prime factor form, Arhan? ऐसा हम क्यों नहीं कहते हैं?
Yes, sir.
Why don't we, in case of algebraic expression, why don't we say that the algebraic expression is also the product of prime factors? Why
Sin-
can't we say that?
Since it contains variables and
Hmm,
unknown numbers.
exactly, that is the reason. So we can't be sure about the variables, right? So this is how the factorizations were done. We were basically decomposing the given expressions right now. Okay, and we also talked about methods of factorization and solved some questions also. I hope you haven't solved the other questions third to question 8. Yeah,
No, sir, since I was not present in the class.
you were not present in the class.
No,
Okay,
sir.
okay. Let me give you a brief. Yeah. So like finding factors of natural numbers is very easy. In the same manner, you can find the factors of algebraic expressions also. Remember, if you attended the class of linear equation in one variable, we talked about what are the factors of expressions. For example, let's say 12p square z. This is an expression. Yeah, that is an expression, right? No.
Yes, sir.
Okay, what are the factors of this expression? It is 12, it is p, it is q, right? And it is z here. So these were the factors.
Yes.
Getting it now? So in if the question is asked that you need to factorize the number right now. For example, there are two expressions here, 4x square and 6x. They are being added here, right? And you need to find the common factor here. You need to do the factorization in this algebraic expression. So what was the method you need to apply? 4x square, if you were to write its factor, you will be writing it like this now. 2 into 2 into x into
Yes,
x,
sir.
right? What can we say about 6x? We can write it as twice 2 into 3 into x. Getting it now?
Yes, sir.
Now, the first method says, the method itself says that the method of common factors. So we have to look out for the common factors. For 4x square and 6x, what are the common factors, Arhan? What factors do they have in
Four.
common? Yes, they have 4. No, they have 2 in common. No, this 2 and this 2.
Oh, yes, sir. Yes.
And they have
And
this x.
X.
This isn't common, right?
Yes, sir.
So here you have got two expressions. They are in addition, and we are being asked to factorize the expression here. So what you need to do, the first step says that take out the common factor. Find the common factor among all the irreducible factors. So we have done that, and the common factor in both of them is 2x. Yeah, 2x, 2x. That is common in both of them. Okay.
Yes, sir.
So we have taken out the common factor. Now the resultant factor form will be the product of the common factor and whatever is left. So what is left, Arhan? What is left here? This 2
2
is left, this
and
x is
3.
left, and this 3. Good. So you will write the common factor, and it will be multiplied with whatever is left. So what is left? This 2 and x, we can write it as 2x,
Yes, sir.
and then 3 is left here,
Yes, sir.
right? Getting it now? So this 3 is left here. Now see, in between the expression 1 and expression 2, they are in addition. The term 1 and term 2 of this expression, they are in addition. So whatever term is left here, you will write the sign of addition in between them and put them in bracket. So it becomes 2x multiplied 2x plus 3. Is that clear?
Yes, sir.
Okay, so that is how you are required to find the common factor using the common factor method, right now?
Yes,
Okay.
sir.
Then you have another method of regrouping. We will come to that in a moment, but before, let's solve few questions so that you get a good hold of the concept. Okay. So the first two questions were already solved. You were not present in the class, right?
Yes, sir.
Okay, see question number 3. Here, the terms are not in addition. You just need to find the common factor in the two. For example, the last question we discussed, for example, 12x and 36. We need to find what factors are common in the two terms, in the term 12x and the term 36. So we can write it like this: 2 into 2 into 3 into x, right now?
Yes, sir.
Twice of 2 into 2 into 3 into 3, right? Now we will look out for the common terms, common factors in both the terms. So this 2 is common here, this 2 is common, this 3 is common here. What is common between them?
2 and 3.
2 and 3 is common them in them.
Yes, sir.
2 is common how many times? 2 times.
2 times.
And 3 is common 1 times only. So it is going to be 4 multiplied 3, that is 12. Got this? So this is
Yes,
how
sir.
you are required to solve it right now. Okay, so solve question number 3. Solve question number 3.
Okay, sir.
Arhan, I have seen you don't keep your camera on in the class. Keep your camera on in the class. All right. Okay.
I will just set up my camera.
Okay. Okay. It's okay then. And how was your test?
So it was easy.
It was easy. Good. Yes. Done. Arhan, have you done the question?
Yes, sir.
Okay. Just tell me the answer. No need to write in the chat box.
Okay, sir.
Hmm. Were you the only one who attended the test? Or Ahmed also attended the test?
Yes, sir. I was the only one.
You were the only one. Ahmed did not attended the test. Okay. Your next test is on 16th, right now?
Yes, sir.
It's on 16. Okay.
Sir, the answer is 15 PQ.
15.
14, sir.
14, no, right? 14 PQ.
PQ.
14 PQ is the answer here, right? That is correct. Okay, good. Okay, solve one more question.
Okay, sir.
Take the question as 39 ABC minus 52 A square B square. Solve this one.
Sir, am I the only one attending the class today?
Yes, you are the only one who has joined today. Ahmad is absent. Okay. I don't know why he's not being regular in the class. Let me drop a reminder for him again. Now notice here, these terms of the expression are in operation of subtraction here. They are not two separate terms, right now?
Yes, sir.
Okay.
So we will use the same method that we used to add.
That we use in the given example. Okay,
Okay.
the example which we discussed, the same method has to be used. Take
Okay,
the
sir.
common factor, multiply it with whatever is remaining, whatever is left out. Okay. After this, you will be able to solve exercise 14.1. Okay. In exercise 14.1, you have to find the common factors. Okay. So that one is very easy.
Okay, sir.
Yes, sir. Done.
Sir, my answer is coming A multi A
Mhm.
uh,
Yes.
AB AB minus
AB minus. Okay. Anyways, let's solve it. Okay. Or if you have got the answer, do tell me quickly. Yes, sir. Okay. Anyways,
no, sir.
look, 39 A B C. It will be written as 3 multiplied 13 multiplied A multiplied B multiplied C. No issue. What about 52 A square B square? How can you write it? You can write it like this: 2 multiplied 2 multiplied 13, isn't it? You can write it like this. A square can be broken like this, and B square can be written like this: B multiplied B. Now, what are the common factors of the two terms here? Yes, sir. And quickly tell me. Common क्या
13
है इसमें? 13 is common. Good.
A
So we We eliminate 13. A is also common. So we have eliminated A also, and
B.
B. B is common here. A and B. So 13 AB is common here, right now?
Yes.
Right. So let's write the term 13AB. Okay. Now, if you were to take 13AB out of this term, what are you left with? You are left with
C.
3C. C and 3, isn't it?
Yes, sir.
Because 13 multiplied 3 gives you 39. So you are
Yes.
left with 3 and C. Minus sign will come in between here. Now, if you were to take 13AB out of this, we cannot go the we can use the longer method also, but now we need to switch to the shortcut method and try to imagine it. So
4
if you were
AB.
to take, it will be
4 AB.
4ab. Brilliant, very good. It will be 4ab. So that is the required prime factorial form. Getting it now? That is
Yes.
the required answer. Okay, the remaining questions you see here, that is one that these ones are also very easy. I would like you to solve question number 8 also here.
Okay, sir. I'll try.
Yeah. And I have not I'm not receiving assignments from your side. Why is it so? Arhan, आप assignments regular share नहीं कर रहे हैं. Why is it so?
Sir,
Hmm?
I will send the assignments that I completed after the class.
Okay, when if the assignments are older one, okay, you need
Okay,
to
sir.
send them as well. Okay. By the way, how many hours you are dedicating to self studies?
Around 5 to 6 hours.
Around 5 to 6 hours. Good. By the way, do tell me which cell organelle does the function of protein synthesis? Protein synthesis. Hmm?
Yes, sir.
Which organ of the cell does the
Yes.
function of protein synthesis? Hmm? Or which organelle is called the powerhouse of the cell?
Am I audible?
Yeah, you are audible.
The powerhouse
Mhm.
of the cell is mitochondria
Hmm.
and
Is it ribosome?
yes, sir, yes, sir, I have some.
Ribosome. Okay, I was checking on you whether you revise things or not. Okay, quickly solve it. Question number 8. We have to move ahead. The next we will be talking about the regrouping method. Okay, so in that we will be collecting the like terms. Okay. Okay. The one we were solving is 3x square y cube.
Sir, I got the answer.
Okay, what is the answer?
It's 4x square y square.
4x square and
Y square.
y square. Look, the first term is no 3x square, then 10x cube y square, 6x square y square z. Hmm? The thing here is that how can you have 4 common in the 3? In the 3 terms, how can you have 4 common? Yeah, let's check it out.
So say
3x
it's
square,
only x square and y square.
x square and
Y square.
y square. Exactly. X square and y square. Getting it now? Then it's correct. Okay.
Yes, sir.
So it was 3 into x into y 3 times. then 10x cube y square. No need to break 10 since there won't be any common terms. Y into y, then 6x square y square z, that is going to be 6 into x into x into y into z, right? So here we see that x is common in all the three. X is common in fact 2 times, and y is also common for how many times? Oh, okay, we need to include this one. It is also common
2 times.
2 times only, right? Right now. Okay, so x is square, y square. Good. Okay, now let's move on to the next method of factorization, where you have to do the regrouping. Okay, okay, this question will be part of your today's assignment. Okay, apart from the anxiety exercise, you have to solve this one also. All right. Now,
Okay, sir.
in the method of regrouping, what you do, we collect the like terms. That is, the algebraic terms are taken together which have common factors and are easy to factorize them. For example, if I have a algebraic expression, let's say pq square minus qn square plus n square. So in order to solve this, what I will do first, I will regroup the terms. So how can I do that? I will bring together terms which consist of, okay, let's take one more term in it. Okay, pq square minus qn square. Let's take minus pq also here. All right, and then let's take plus n square. Now, let's solve it by the method of regrouping. So first thing first, you will regroup the like terms. And when I say the like terms, what do you mean by it?
Like variables.
Like variables, like 3pq or like 3p square qq. They are
Yes, sir.
going to be like terms, no matter how much the power is. So you will do it like this: pq square minus pq. Right now we have grouped the two terms together here,
Yes, sir.
and then plus n square minus qn square. Although they are not like here, but they have common n square common in both of them. Getting
Yes,
it
sir.
now? So that's what we have done here. Now see, in pq square and pq, what is common? Only p is common in both of
Yes,
them,
sir. Yes, sir. Yes, sir.
and 1q is common in both of them.
Yes, sir.
So it means pq is common in both of them. So from pq square, if you were to take pq
Yes.
square, if you were to take pq, you are left with only q.
1.
No, you are left with only q now. Look here. From pq square, right now, if you were to take out pq, you are left with only q now. So you will be writing q here. Okay, and here it's going to be 1. Good. Okay. Then here the common is what? Common is n square. Getting it now? So you are left here with what? 1 minus q. Getting it?
Yes,
Now
sir.
here's the interesting thing here. Look here, we can write it like this: pq plus n square can be written together here. Okay, but the thing here is that q minus 1 and 1 minus q. Yeah, can we do some changes in them and make them make them look similar to each other? You know, 1 minus q can be written like this: q minus 1 if outside the bracket I were to write minus sign.
Yes, sir.
What do I mean? Like 5 minus 8 can be written like this: 8 minus 5, only if
Yes,
I
sir.
were to write minus outside the bracket, because 5 minus 8, I know it gives me minus 3. So in the bracket it is going to be 3, but outside I have to place minus sign as well here.
Additive inverse.
Additive inverse. Getting it now?
Yes, sir.
So here what can we do, Arhan? Tell me, how should we write it? Hmm?
So we can add minus in front of q outside the bracket.
This plus has to change to minus. Okay.
Yes, sir.
because here no, you were not having any variables, right? No, but
Yes, sir.
since you have got a variable here, just before the variable you need to change the sign. So it's going to be q minus 1 here now. Now what is the common term? This q minus 1 is common in both the terms now.
Yes, sir.
So it can be written like this: pq minus n square into q minus 1. Is that clear?
Yes, sir.
This is how you can write it down: pq minus n square into q minus 1. Hope that is clear.
Yes, sir.
Okay, so let's solve few questions then.
Okay, sir.
Right. Okay, so here you have got this question. Solve this question:
Okay, sir.
3x square plus 2x plus 12x plus 8.
So since they are like variables, can't I just add them?
Like variables, yeah, you can add them, but you will be having inconvenience in solving the question then. Okay,
Okay, sir.
so just take the common out of them, regroup them first and then take the common. After we are done solving this question, you will be solving one more question: x square plus xy plus
Okay, sir.
8x plus 8y. Hmm. This one is very easy. Okay. In fact, if you were to even not regroup the terms here, it can still be solved. Okay, it can be solved without regrouping the terms.
Yes, sir. So is the final answer 17x squared plus 8?
17x square plus 8. I suppose you have multiplied the factors. You don't have to multiply the factors right now. You have to find the factorial form of the expression. Factorial form of the expression. You don't have to multiply the factors. Look, it has to be solved like this. In 3x square and 2x, what is common? X is common now. So we can write it like this: 3x plus 2. In 12x and 8, what is common?
12
Yes,
and 8.
12 and 8 is common here. What are you saying? In 12x and 8, 4 is common now.
Yes, sir.
In 12x and 8, what is common? Look here: 2 into 2 into 3 into x.
4.
Yeah, so 4 is common here now. Good. So it will be 4 taken out of the bracket. It will be inside the bracket. What term is going to be? Just do tell
3n
me.
plus 2.
3x plus 2,
Yes, sir.
right? So you have got What you have got the common terms 3x plus 2 here. And as we know that once you have got the common factors, you can separate it out and you can multiply it with whatever is left. So what is left? X and 4 is left.
4x.
And they are in addition. They are going to be in addition because the terms of the expression here are in addition. These two terms are in addition here, and it will be in multiplication right now.
Yes, sir.
So this is the required answer. Hope it is clear. Okay.
Yes,
Okay.
sir.
See the next question and solve this one.
Okay, sir.
Yes, Aran. Have you solved the question?
Just wait a second, sir.
Okay.
I've got the answer, sir.
That is how much?
So it's x plus y bracket 8 plus x.
8 plus x. But in the standard form, always write the variable first. X plus 8. Okay.
Yes, sir.
Good. What about the third one? Solve this one also. The first one is correct here.
Okay, sir.
Okay. X plus, the answer came to be x plus y into x plus 8, right?
Yes, sir.
I think there's only 2 exercises in the chapter, or there's more. I think there will be at least 3 to 4 exercises in the chapter because you have to study about divisions also. You have to study about multiplication also in this chapter. Okay.
Sir, I found the answer.
What is the answer?
It's a plus b x minus y.
A plus b multiplied x minus y. Good.
Yes, sir.
That is correct. Well done. Okay. So we can move on now to the next part of the chapter, that is factorization using identities. So far, we were using the methods of common factors and we were regrouping the terms in order to find the factorial form. Now you will be studying about factorization using the identities. If you remember in the previous chapter, we dealt with some of the identities. What were the identities? Do you recall? Name some of the identities. Algebraic identities.
Sir, in which class?
In the chapter algebraic expressions and algebraic identities, we proved and we studied about some of the identities like a plus b whole square equals to a square plus 2ab plus b square.
Sir, I think I was not present in that class.
You were not present.
No, sir.
Okay, look now. In the previous class we studied, in the first part of the chapter, I guess you were present in the part algebraic expressions. In the Okay, let me give you a glimpse of it. Algebraic identities. So there are some of the algebraic identities. For example, if a number, if a variable a and b are being added and being whole square, then it can also be written like this: a square plus 2ab plus b square. You will ask, sir, how can we write it like this? So I will say that it is same as 5 plus 3 whole square. Okay, so in order to do that, what you do, it becomes 8, and 8 into 8, then you get 64. Right now,
Yes.
what if I were to say that I can square 5, I can square 3, then I can multiply 5 and 3. So I'll be getting 25 and 9. Then I will be getting what? 2 into 5, 10, 10 into 3, 30. Right now. So 25 plus 30 gives you how much? 55. 55 plus 9 gives you 64. Yeah.
Yes.
So in that way also we are if you were to break it and then add it, we are also getting 64. Or if you were to simply add them and then whole square it, you were also getting 64. In the same manner, if you have got this expression a plus b whole square, it can be written like this or not, Arhan? ऐसे लिख सकते हैं इसे हम?
Yes, sir.
Okay, and you know, like you have to multiply the first term a with the both of the term of the second term here. Like
Yes, sir. And
it's going
be
to be exactly, and b with
the whole.
the whole. So it's going to be a square plus ab plus ba plus b square. Right now, so it's a square
Yes, sir.
ab plus ba, that is 2ab. Right now,
Yes, sir.
it can be written like this. So you are getting the identity here. So these are some mathematical proofs in the algebraic expressions that we studied right now. So out
Yes,
of
sir.
them, this was the first identity which you have to remember. The second identity, suppose if you have, if you have to have a number like this, 8 minus 5 whole square, that will be giving you obviously how much? That will be giving you how much?
Um,
9, isn't
nine.
it?
Yeah, 9.
Okay. Or if you were to do it like this, if you were to do it in the form of algebraic identity, then also you'll be getting 9. For example, how do we do that? Yes, if you were to square it, if you were to square 5 also, and if you were to
Multiply.
multiply 8 and 5 with minus 2 here, so you will be getting what? 64 minus 80 plus 25. Yes.
Yes.
So how much are we getting here? Look, let's see if we have done some mistake here. 8 square is equal to 64, right? 5 square is 25. 2 into 8 into 5, that is 80 here. 64
Yes, sir.
minus 80 plus 24, right now. So
Yes,
that
sir.
gives you how much? 64 minus 80 is 64 minus 80. Quickly tell me. That is
24.
6. What are you saying? That is 16 now, minus 16 in fact. Minus 16 plus 25 gives you how much?
9.
Obviously 9. So that in that way also you are getting same 9 now. Okay.
Yes, sir.
Okay, we will also try to prove that also. So the second identity was a minus b whole square is equal to a square minus 2ab plus b square. This one we just saw. इसे हमने just अभी prove किया using the number
Yes, sir.
8 and 5. You can prove it using the variables also. If you like, I can explain that one as well. Okay. So you can write it like this now: a minus b multiplied a minus b. Then it will be a square minus ab, right now.
Yes, sir.
Then it will be minus minus b multiplied with a here. So it will be minus ba. Then
Minus
minus
b
b multiplied
minus
minus
b
b.
square.
Minus b square. Okay, it will no, it will be plus b square
Yes,
now,
sir. Plus b square.
right? So a square minus ab or minus ba, both are same. So you can write
Yes.
it like this: minus 2ab now plus b square, right? So hence it is proved that a minus b whole square is equal to a square minus 2ab square plus 2ab plus b square, minus 2ab plus b square. Is that clear?
Yes, sir.
Okay. The third algebraic identity was that if you have terms like this, a square minus b square, then it can be written like this: a plus b multiplied a minus b. Okay. So
Yes,
these
sir.
these are the three identities which you have to memorize. Okay, what was the first identity which I told you? You tell me. Hmm?
It was a square minus plus b square is
Hmm?
equal to a square plus 2ab plus b square.
The first one was a plus b whole square equals to a square plus 2ab plus b square. If you said this one, then it is correct. What about the second one? What was the second identity?
It
दूसरा क्या था?
was
Hmm.
uh,
Mhm.
it was a plus b.
Just in place of plus, it was a minus b here. Okay. A minus b whole square. Right hand side पे हमने क्या लिखा? We wrote a square
A square minus 2ab plus b square.
plus b square. Okay. Third one.
It was
Hmm.
a plus b multiplied by a plus.
First, you have to write the left hand side identity. No, left part of the identity. So it was a square minus b square. So you can write it like this: a plus b multiplied a
A
minus
minus
b.
b.
Okay, so I hope you will remember all these three identities which are very important.
Yes, sir.
Okay, so you have to memorize these three identities and these will be used right now. Okay,
Yes, sir.
for example, if you were to factorize, let's say, take an example here. Let's say you have a term 4y square plus 12yz plus 9z square. Try to factorize it. Then I will be telling you how you can use the identity method to solve this.
Okay, sir.
Mhm.
So can I solve it through any method or I have to solve it through the identities?
You can solve it through the identity also. Okay. In fact, since we have already discussed identities, we can solve it using the identities also. But you solve it just like you were solving the previous questions. Okay. Then you will observe that it can be solved using the identity also. Okay.
Okay, sir.
Just don't assume any identities while solving the question. Just solve it like you solve it naturally. Okay. Hmm.
Okay, sir.
Hmm. So Arhan, your parents must be planning to take your admission in class 9. No, you will be taking admission in class 9, right?
Yes, sir.
Okay. In India or outside India?
India.
In India. Okay. Preferably, I suppose it will be in Delhi, right?
Yes, sir.
Okay. Look, the questions which you were solving earlier, like the questions like this. Hmm. The question had how many terms? It had one, two, three, four terms.
Yes,
This one also had four
I'm not
terms.
able to solve
Exactly.
factorizes.
This one also had four terms right now.
Yes, sir.
But here have got three terms. So the
Yes,
expressions
sir.
that have three terms that can be solved using the algebraic identities. Not in every case, but it can be most easily solved using the algebraic identity. So if you were to observe the term, observe the first term, second term, and third term. Is it in the form of a square of some algebraic expression?
Yes,
Is
sir.
4y square 4y square, is it the square of 2y?
2y whole square.
Yeah. Is 9z square the square of 3z?
3 into 3 z square. Whole.
Yeah, it's the square of 3z.
Yes, sir.
Or isn't 12yz actually equal to what?
4 into
2 into 2y into 3z,
yes, sir. Yeah.
right now. So it is forming, it is related to which of the identity? Which of the identity can be used to solve this one? Hmm? It's a square. Okay, Rahan. This one is b square. And this one is, we can actually see it's in the form of 2ab.
Yes,
Yeah.
sir.
Okay. And if you were to see the sign, it's positive here. It's a plus sign here. So that
Yes,
means
sir.
which identity has been used? Which
First,
identity can be
I.
used? The first one will be used. So now we can solve it easily, right now. So it will
Yes, sir.
be 2y square plus, how do you expand it? 2 into 2y into 3z plus 3z square. Getting it now?
Yes, sir.
Okay. So this is how it can be solved. Now let's use the identity. Okay. Now here, how it can be written like this: a plus b square. It is also same as a plus b multiplied a plus b now. Yeah.
Yes.
Okay. So this expression has been broken like this, and we actually observe that it is actually of this form here: a square plus 2ab plus b square, right now. And I can
Yes, sir.
also write it like this also: a plus b multiplied a plus b. Is that clear or not? Because a
Yes,
plus
sir.
b whole square simply means a plus b multiplied by itself. So I can write it like this: 2y plus 3z multiplied 2y plus 3z. Isn't it?
Yes, sir. Yes, sir.
Can we not write it like that?
We can.
We can, obviously. Why? Because actually this actually is what? 2y plus 3z whole square. It is the expanded form of this expression, that is 2y plus 3z whole square.
Yes, sir.
Okay, that is clear now.
Yes, sir.
Okay, let's solve few questions if you have got some questions in your inside exercise. Okay, now this one has used different identity. Okay, try to solve it quickly.
Okay, sir.
Hmm. By the way, which identity you will be using? The first, second, or third? Okay, repeat the first identity. What was the first identity which you used?
It was a
Hmm.
plus b whole square is equal to a square plus 2ab plus b square.
Second one?
It was a minus b whole square is equal to a square minus 2ab plus b square.
Plus b square. The third one?
It was
Yes, that
a
was
plus
a square minus b square equals to a plus b into a minus b.
yes, sir.
Okay. A square minus b square is equal to a plus b multiplied a minus b. So you will assume the first one as a here, the term under the bracket as b. Now it can be solved easily. Quickly solve it.
Okay, sir.
Prior to this chapter, have you completed every question of the NCERT textbook or not?
Yes, sir.
Prior to this chapter,
Yes, sir.
till the last chapter which we did was, I guess, direct and inverse proportion, right?
Yes, sir.
Okay. Have you completed all the exercise questions till direct and inverse proportions?
Yes, sir.
Okay. If you have done, do send your assignments to me. Okay.
Okay, sir.
Mhm. Yes. Have you got the answer?
Not yet.
Okay.
It's x square, right?
It's x square. Yes, it is x square. Okay, look here. It's to be written in the form of a plus b multiplied a minus b. You have got the term. So it will be simply written like this. See over here. And it will be x plus 2x minus 1 multiplied x minus 2x plus 1. Okay. Y plus 1 here and y minus 1 here, because these are the terms x and 2x minus 1. These are a and b here.
Yes,
First,
sir.
you have added them here. I have added them here. Now I have to subtract them. So it will be x minus 2x minus 1. So it becomes x minus 2x plus 1. Minus sign is being multiplied with the terms inside the bracket. So here you are left with 3x minus 1, and it is minus x plus 1. Getting it now? So this is the required factorial form. This is how you factorize this question. Getting it now? I hope it is clear now.
So we can so we can further simplify it.
No, there's no need to further simplify it. How can you simplify it further? If you were to further simplify it, you will be multiplying the terms. Then you will again come back to this expression: x square minus 2x minus 1 whole square. You will be getting the same value, no? So you have to find the factors, not conclude the answer. Getting it now? Okay, then so